Greetings and welcome, friends. Mr. Wada here. We're going over page 441 on 8.3 here with my friends in real life, showing you, our internet friends, how to do some similarity. So it says, in exercises 3 and 4, determine whether triangle JKL, all right, so that's this one, or triangle RST, this one, is similar to triangle 3. Someone walk us through, how could I try or attempt to do that? Looks like I've got lots of sides here. What are our thoughts? I could compare sides and, right, kind of consider the possibility of side, angle, or sorry, no. It was side, 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 similarity theorem, right? 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 So let's see if we can compare sides. How do I know which one to compare the 8 to? Like, should I compare the 8 to the 6? How would I know? Why do I do it to the 7? Does anyone know why? I mean, it looks like those line up, but I should compare the smallest to the smallest, right? The mediumest to the mediumest, and the largest to the largest, right? That would make sense if I'm trying to prove similarity. So that's what I'm going to end up doing. So let's see, is 7 to 6 the same as 8 to 7, all right, so 7 to 6, is that the same as 8 to 7, and is that the same as 12 to 11? None of these fractions reduce, those are not equal, so therefore those are not similar. Oh, question, comment? Okay. Right now, yeah. And then I'll compare it to this one in a moment. Yes, yeah. So those two are not similar. Not similar, right? Okay. So now let's try it for these ones. So once again, I'll compare the smallest to the smallest. So 7 is to 3.5 as 8 is to 4. I've got a good feeling about this one, guys. As 12 is to 6. And it looks like, yeah, that reduces to 2 to 1, and 2 to 1, and 2 to 1. So these are similar. Similar. There we go. By the side, side, side. Similarity theorem, right? So that's what I had to do. All of the sides are proportional, and then yesterday we decided to come up with our own notation where we put like little squiggly mark, right? Those two are similar, those two are proportional to each other, and triple squiggles. All right, that all of those sides are proportional to one another, their ratios are equal, and therefore the triangles are similar. Okay, here's question 6, the request coming in. It said, find the value of x that makes the triangles similar. Where's x? Did I grab the wrong problem? That is excellent. Okay. Maybe that's tonight's problem? Let's see. Where did I get this problem from? Oh, that was the Prac 8.3. There's my problem. Okay, let's see. All right, here we go. Breaking the fourth wall. Whoop, 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 whoop. No. Let's see. Select and copy. I'm working on it, friends. Good save, though. At least I wasn't doing the wrong problem. And uninvert. Here we go. Back into normal space. There we go. That's the right number 6. Is that what you wanted? All right. So yeah, we talked about one of these yesterday as well. If I want to find the value of x that makes these triangles similar, I'm going to have to compare similar sides to similar sides. So I could do longest to longest, but I don't know. Maybe I want to avoid the decimal and I want to avoid the distribution. Let me just aim for these two quote-unquote legs here. So I'll say 4 is to 8, right? Smallest to smallest, as mediumest is to mediumest. So as x minus 1 is to the 10. All right, and this should be sufficient for me to do a comparison. I can reduce the 4/8 4 goes into both of those. 4 goes into 4 once and into 8 twice. So I will have 1/2 equals x minus 1 over 10. Some of you guys I know liked to do the cross multiplication. That's perfectly fine. We'll do cross multiplication this time. Tell you what. So cross multiply. 10 times 1 is going to be 10, and 2 times x minus 1. Tell you what, I'll be super careful making sure you guys distribute. That could have been a super common place to make a mistake. So I'd have 2x minus 2 equals 10, and then add 2 to both sides, and then divide both sides by 2. X equals 6. All right, there's a lot of different ways you can set up these proportions and have them work out. I could have inverted both of those. I could have swapped the means and the extremes of the proportion. Is back, I don't know, probably middle school. You guys remember that? Lots of different ways to set it up, but the idea is compare similar sides to similar sides, and it works out. Any questions on that? No? I picked both 9 and 10. It says determine whether the two triangles are similar. If they are, write a similarity statement and find the scale factor. Okay. So what's your route for question 9? What do you think we could do? Actually, both of these look like I'd use the same route. What method do you think I'm going to try? What means do we have to prove similarity? Right, I'm going to use side angle side similarity theorem, right? SAS. We also have angle angle, and we also have side 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 now. So in order to do that, let's compare the ratios of the sides. I already see that I've got 2 angles that are congruent to each other because all right angles are congruent. So let's see, is 8 to 6, little to little, the same as 12 is to 9, medium to medium? And 8/6 reduces to 4/3. Whoop. And 12 and 9 are both divisible by 3, so that's also 4/3. So the sides are, in fact, proportional to one another. All right. And so by side angle side similarity, those triangles are similar. So what is the similarity between them? If I'm going to come up with a crazy name for the first one, triangle fed. What would the corresponding triangle name be that matches that? Let's see, I went from, acute to right, and yeah, so Y, X, W, I agree. And yeah, there's a bunch of different ways you could have named your triangle as well. The scale factor to go from one to the next, depending on which direction you're going, is just going to be the 4/3 or 3/4, depending on what you got. Let's see real quick here. I've got matching and therefore congruent angles by def of Kong. And let's compare small to small and medium to medium, 18 to 24. Let's see, 2 goes into that, 4/5. I don't have a good feeling about this one. 6, oh, it looks like 3/4. So that is not proportional, therefore these are not similar. Right? And I think I picked one more problem for us. Question 14, I believe. There we go. Show that the triangles are similar and write a similarity statement. Explain your reasoning. All right, you guys can spot this a mile away. What do you think we should do? I can't. All right, so we got vertical angles jumping out at us. Vertical angle theorem. So it looks like I'm aiming for side angle side similarity. And so I should compare, right, small to small. I guess I'll do 14 over 21 instead of 21 over 14. It doesn't matter. And then I'll do 18 to 27. And let's test to see if these sides are proportional. So 7 goes into 14 twice and into 21 thrice. And 9 goes into 18 twice and into 27 thrice. So therefore, these sides are proportional to one another. And by side angle side similarity theorem, we would be able to prove that those triangles are similar, not congruent, So I'll say ABC, triangle ABC is similar to who now? Let's see, I got the one squiggle mark from A to B. Okay, so I've got to go from D to E? DEC, yeah. All right, so there we go. So thanks for watching, internet friends. Have a great day. Bye-bye.